Okay, so today we're going to look at inverse functions, okay, and there is one reason why we go over this particular topic and learn a very particular formula that you will only ever use really just once, okay, and the reason that we go over all this business with this is because every single AP test there is a question. There is one question on this topic. It doesn't go into anything else. It doesn't necessarily it kind of follows from some of the stuff that we do, but I don't know, to me it seems like a very silly thing, but I know that it always shows up as a multiple choice question, and so I would hate for you guys to lose points potentially because I just decide to not show you something, but it seems just kind of arbitrary.
Is there only one question on the AP?
There is one. It'll be multiple choice, most likely, and like on our test coming up, not this week, but probably next week, that we will have probably just one question, but again, just kind of mimic what you see on the AP test, and we'll kind of see it. But first, before we get into what that calculus concept is, we're going to refresh our memory a little bit about inverses, just to make sure that we kind of understand what inverses are and all that good stuff. So, way back when you guys first learned about functions, all right, sometimes you weren't given just like a function rule, like you weren't given like f of x equals x squared plus 2 or something like that. Sometimes you were just given like a function relationship. So we could say something like this, like f is just a set of ordered pairs. All right, and that makes it, that's a function, right? It would, like if you were to graph these ordered pairs, it would pass the vertical line test. None of the x coordinates are repeated and go to then different y coordinates, so you wouldn't have, you wouldn't have two coordinates on top of each other like that. That would then fail the vertical line test. So it's a function. Okay. Right, I don't know. Can you remember how long ago that was? 7th grade, okay. Okay. You just
that was a very dark
banished those. Yes, it's a dark time in many people's lives. 7th grade's the worst.
It was.
So, yeah.
Especially, mostly because of Miss Harris.
Oh, well.
It was like being in a horrible time of your life and then just having Satan come.
Nice.
She's like, 5%.
So if this is our function, all right, then the inverse, do you guys remember what do we do to get the inverse? Yeah, you just flip the x's and the y's. Nope, you just flip them. Okay.
Remember the video of her daughter explaining inverse? No, it was opposite reciprocal.
So there it is, 7-4.
I remember one time I had a 0% on a quiz in that class. I got nothing right.
Okay.
Yeah, I think that's his first problem.
So, the definition of an inverse function. So what makes something an inverse? We already have. I know, we can vent about our terrible times in 7th grade another time. We can have a little pity party in a session, because I also did not like 7th grade too. It was pretty awful. All right, and I didn't even go to the Walkersville Middle School, so I think it's just a universal truth. That's right, I just skipped 7th grade.
That was homeschool.
Right. So, inverse functions, we already should have an idea of inverse relationships. So for example, right, whenever we see an equation and we want to get rid of addition, we use the opposite of addition, subtraction, okay, and they cancel each other out. They are inverses kind of one another. They cancel each other out. They undo each other. If we see a square, to undo that, the inverse of squaring something, or the opposite kind of, right, is the square root, right? So these are inverse operations. They undo each other. If we have natural log, we raise each side to the e power, or e to the power of each side, to then cancel out natural log. Or if we have e to something, we do natural log to both sides to cancel it out. So, an inverse function, it's a function. Okay, we'll say this. It's a function, a function g is the inverse, okay, of the function f if, and I'll put a little colon there, so a function g is the inverse of the function f if f of g of x, so if I take g and plug it into f, that should result in just x. Like everything should cancel out and I should get just plain old x there. and, so that was me plugging G into F, and if I plug F into G, so that'll be G of F of X, that also should yield just plain old X. Yes, like X squared and the square root of X. When you plug square root of X into X squared, you get X. But when you plug X squared into the square root of X, you get plus or minus X. So it doesn't exactly match up there. Okay. All right, so let's take an example of that. So we're going to show that F and G are inverses of each other. All right, and we'll have f of x equal to 2x cubed minus 1, and g of x equal to the cube root of x plus 1 all over 2. All right, question, Don?
Would we get a question that is worded like that, and then if it wasn't, we have to show it?
Basically, yeah. So, yeah, you could. So, like, you could to reword it. Then it'd be something like are f and g inverses of each other. Show your work or whatever kind of thing. And so then so we go through that work, yeah. But again, this is more just like what I say, like kind of like introduction to then refresh our memory a little about inverses, the calculus stuff that we're going to really be responsible for is coming up. Okay, well this is like pre-calculus, maybe in algebra 2, I don't know. Anyway, so f of g of x, right? We'll do that one first. So that means I'm going to take my g function and plug it in to f. Okay, so g is going to replace the x here. All right, so it's very important, right? G is going into the f, so I'm going to take this function and plug it in here wherever I see what variable? X. That's right. So it's going to be 2 parentheses cube root of x plus 1 all over 2 cubed minus 1. All right, and so then now we want to try and simplify this. So if we cube a cube root, what happens? It goes away, cancels out, right? So now I'll have 2 times the quantity x plus 1 over 2 minus 1. And then what can we do next? 2's cancel. So now I'm left with x plus 1 minus 1, and so we get just plain old x. So we've shown then that f and g are inverses of each other. But we haven't shown that f and g are inverses of each other, because you got to do the other direction too. So you guys go ahead and do that real quick. Go ahead.
Don't do it.
I don't know how to do this.
Good. No, just kidding. What am I looking? So simplify the numerator first, I would say, right?
So just like put cube root of
Look at these. Minus 1.
All your order of operations.
It is X.
Okay, good setup.
Yeah, I agree with Art.
Oh, I see it.
Oh, yeah. I didn't do the war operations already.
See, look, you get 2x cubed over 2, and 2's cancel, and it's just cubed. Well,
You gotta check this guy, what you missed.
X.
Because you have 13 over 2 cubed at the and then like cancel the 2's, and then take cube root like cube.
I've been waiting for this. I actually, but like normally I wait because I know they always have the expansion, and then they release Game of the Year edition, and they'll get all the expansions every now and then. The expansions for Bethesda are usually pretty good. They're not like fall. Here's a new map. So like, am I excited for it? Because I watched them on Twitch last night a little bit. But I was been watching Bomb Block on Twitch too.
Who's telling everybody to get on the phone?
Were you watching the countdown last night?
No, it was a countdown.
Wait, countdown. You gonna get blocked screen.
Oh, okay. To like bring it back or whatever? Oh, I got you. No, I just thought it was back.
Mr. Wood,
no one knew it was like countdown. What?
PT?
Yeah, so, but then like,
He's like, what? Mr. Win, download H1Z1 and play it with me.
is it free? Is it free to play?
No, it's like $20.
Oh.
It will be free to play when it comes out.
Play with Ryan, no.
Ryan, $20.
It's an alpha.
Oh, okay. Ooh, alpha?
Yes,
I do not. I have to get that at some point. I see a source, yes.
Alright.
Okay, sometime. I will talk later. All right, so
There
there it is.
He doesn't want a source.
You guys are gonna 1080 no scope me. It's gonna be terrible. All right.
Yeah, we have a mumble.
Oh, do you really?
Yeah, we have that.
Oh my God.
Yeah, we have TeamSpeak too.
All right. Well. All right. We gotta get back to teaching. Shh. All right. So anyway, there it is. You get X, right? All right. X and X, and that's it. All right.
This class is great.
All right. So let's try some more here. Now we can also find the inverse. That's right. So now let's try and find an inverse. I'm going to come up with an inverse. And you guys might remember this. So we take our function. Okay. And remember up here at the very beginning, right, we wanted to find that inverse. We found an inverse already, didn't we? Like that function. I'm going to kind of scoot this way back. Okay, right there. It fits good. We took our function, and what did we do to find our inverse here? Swap the x and y's. Well, guess what? In a function, when we want to find the inverse of a function, we swap the x and y's. All right? And then once we swap them, we want to resolve for y. We want to get y in terms of x. All right, so to get the y by itself here, you're going to square both sides to get rid of that square root. So you get x squared equals 2y minus 3. And then what should we do? Anybody? Add 3 to both sides. Equals 2y. And then, yeah, divide both sides by 2. Now, you can just put, that means you can put then x squared plus 3 all over 2 if you want to. That equals y. You could also break this up, right? So when we have a numerator and a denominator, right, like a fraction, you can break the numerator up over the addition or subtraction and then just put it over the denominator. So this can become like, for example, what I mean is you can make it x squared over 2 plus 3 over 2. If you want to write it that way, that's fine as well. Okay? And again, that's your y. Now, because this is an inverse of f, we actually have a way to denote inverse, right? In math, it's the function, but then we put a little to the negative 1, like that, of x. This means the inverse. The inverse of f. This is not, yeah, so I'll hit that in a second here, so I'll write this down. So it's x squared over 2 plus 3 over 2. Okay. And so that is the inverse of the function f. Okay? So you might be like, wait a minute, Mr. Whitmire, when I see something raised to the negative 1 power, that just means I'm supposed to, what we normally do when we see something to the negative 1 power. Like 1 over that thing, right? It's like x to the negative 1, that's 1 over x. We never said that was x inverse, so how am I supposed to know this is not 1 over? Well, if it's 1 over, you'll see it like this. Okay, that means 1 over f of x. Okay, if you see f with a little negative 1 like that, that means it's f inverse. Just like, right, we saw earlier, yesterday, arc sine of x, right? Another way to write arc sine of x is sine inverse of x. These mean the same thing. Remember that? if you see, so how do you know then when it's sine to the negative 1? Well, it'll be something like this. Sine to the negative 1, that means 1 over sine. Okay, not arc sine, yes.
So on the one before, the one we did before this and this one,
Yes.
it was like the exact same format of problem. Like, so for 3 root x plus 1 over 2, or no, for f of x equals 2x cubed minus 1, it became cube root x plus 1 over 2. Like the
Yeah.
Drew, shut up.
No, it's similar. I see what
It's
you're
just
saying.
like,
There's
so
a
the coefficient just went in the denominator.
basically, but again, it's just, I mean, there are patterns
There's
here,
no,
but
there's
it's,
no like actual pattern. that you're not
well, there is,
looking
but
at.
it's because I set it up so similarly to the last one that's why it just looks very similar.
But it's not like a shortcut.
No, I would not, yeah, I mean, I'm glad you're looking for that kind of thing, but in this case, I don't think we're gonna come up with any sort of general shortcut or anything.
See, Drew, I think that was 5%.
That was a fine question.
Okay.
5%. I just felt like.
How rude.
All right, moving on. So, let's take the derivative of an inverse function.
Okay. Calm down.
And now we're up to an 11, all right, so. So let's do some calculus now.
Sure about that.
Or we're going to examine the derivative of an inverse function, I should say. All right, so here we go. So actually we're going to need our graphing calculators here too. We're going to graph the functions. Okay, so here we're going to graph those two functions using our graphing calculators. So if I want to graph x squared, but only for x values greater than or equal to 0, I'm going to type in x squared, and then what do we got to do? Divide by, and then parentheses, x, and then the second math, to do the test menu, and we want to be greater than or equal to 0. Okay. So that will ensure that we only graph x squared for x values greater than or equal to 0. Right? Remember, the way this works, it uses the kind of like, the truth, what do I want to call it? Yeah, basically a truth table, but it's binary, like kind of the binary truth system, I guess, or whatever you want to say. If something is true, the calculator returns a 1. If something is false, the calculator returns a 0. 1 is for true, 0 is for false. So for x values greater than or equal to 0, it will return a 1, thus graphing the x squared. If we're anytime we're dealing with x values less than 0, then it will return a 0, and then it won't graph it because it'll be undefined. Right? That's how that works. And then square root of x, a little programming, okay, right there. And so we'll graph. Okay, and okay.
It looks like cool.
Now, let me go back. So this is, you're probably like Zoom 6 maybe is what yours probably looks like. Okay, now, looking at this, you might not be able to see the relationship because the screen is a rectangle, but it's fitting a square onto a rectangle here. So what I mean is, like, these go from negative 10 to 10 this way and negative 10 to 10 this way, but obviously if you're going from negative 10 to 10 this way, they're going to be stretched out more because, the screen's wider than it is tall. So we can fix that by, if you go into zoom and then square, it will like fix it so that it squares up the pieces. So zoom square, zoom and then 5 squares it up. Okay. So graphically speaking, there is a relationship between a function and its inverse. Can anyone see what it is? Emma? So, right, oh yeah. So again, graphically speaking, there is a relationship. There's actually a transformation. If you guys remember back to geometry, there's a transformation that we can do here.
It's a 90-degree rotation. Well,
So it's
And-
not a
and
rotation.
flip over
Look at this.
a reflection.
It's a reflection over the line y equals x. If I kind of like, let's see here, if I can draw, I think they do dotted lines. Yes. Oh, that didn't really help. But there's the line y equals x. And so you can see that this piece and this piece, they are reflected over the line y equals x. Okay?
So is that true for all inverses in general?
All inverses are, yes, are reflected over the line y equals x. Yep. Shh. So there you go.
Interesting.
Right? If we were to graph those like cubic functions that we just talked about, you would be able to see that they're both reflections over the line y equals x.
Would there ever be a graph, or actually an inverse of a graph that reflects over the line y equals negative x?
No, it wouldn't be the same thing.
Okay.
Because again, the thing that makes it an inverse, what do we do in the first place? We're swapping the y's and x's. So if you reflect over the line y equals x, it just swaps the y's and the x's. Creating that. Okay, step 2. This is kind of like introducing the formula that we're going to be using, the little concept we're going to learn that's going to have one multiple choice question, most likely multiple choice question on the AP test. Okay, so it's kind of introducing that topic, trying to like at least maybe giving us an idea about why it works or how it works and stuff like that. So, what is the ordered pair for f at x equals 3? So you can use your calculator if you want to do that, or you can use your excuse me, you can use your well, just what you know about f, right? So you can use the function. So what would be the coordinate there of for f at x equals 3? So yeah, the point would be 3, right, for the x coordinate, comma 9. Two ways you can do that. You can just plug the 3 in for the x, square it, gives you 9, or you can just find it on your graphing calculator too. Remember to find a point on your graph. You can do second trace. You can go to value, and it's waiting for an x value to plug in, so you can type in 3, okay? And so you can see that x equals 3 gives me 9. Now you got to be careful. You can see that it's using the y1, which is what we wanted it to do. Okay, I'm not sure how we would get it to work if we wanted it to be the y equals 2. Oh, there, you just press the arrow up, down. Okay, so press the arrow up or down, and it'll take you to then. So there's in for G, but we wanted the ordered pair for f. So there it is, 3, 9. Great. Right, that's another way to do it too. You could use the table as well. Absolutely. Yep, lots of options. All right, so what is the inverse point? So if 3, 9 is the ordered pair of the original function, what would the inverse of that have to be? Yes. Yeah, 9, 3 is swap the x's and the y's, make the 9, 3. Okay, so find the slope at the ordered pairs we just found. Okay, how do we find the slope at a point? In calculus, right? We use the derivative. So if I'm going to find the slope at 3, 9, that means which function am I taking the derivative of?
The first one.
The first one, right? Because this point is on f. So it's like we want to take the derivative of f, find the value of f prime then at the 3. Okay? So let's see here. So the slope at 3, 9. Oops, I got to take attendance here too. I forgot. Every time. Boop. Boop.
That was like 15 minutes ago.
Yep, it did. Probably more like, yeah. Anyway. That's right. Mumble and Bob Ross and Happy Little Trees.
I love that idea, Connor.
I was going to say, yeah. All right, anyway, so find the slope of the ordered pair we just found. So the slope at 3, 9, the slope at 3, 9, what is that? Anyone got it?
Yeah. C.
2, 6,
I had
9, kidding? So let's see here. Again, our function is, so f prime is what? 2x.
Yeah.
So the slope then at 3 would be 2 times 3, so it's 6. Okay. So there it is. Alternatively, we could use our graphing calculators, right? And let's see, I'm going to clear out this thing here. We can do second trace. If I want to find the value of the derivative at a particular point, what command do I use? Number 6, dy dx. Just got to regraph everything here. All right, I want to find the slope at 3. Sorry, 3. So 3, enter, and there it is. dy dx is 6. You can see that it's on my x squared thing. If I press arrow down, yeah, no, it does not give me the slope there. So, again, somehow it knew that I wanted that first one. I don't know what would happen if you wanted to try and get the slope for this one. Actually, I think we're going to do that in a second here. So, but anyway, so there it is, 6. Okay, so the slope is 6, which we knew that already. All right, now we're going to find the slope at the other point. At the point 9, 3. Okay, that's on the inverse then, inverse function, so which is the square root of x. Excuse me. Okay. So I could say here g prime of x, right? That's equal to what? 1/2 x to the negative 1/2. And so therefore I'm trying to find g prime of 9. And so I'm going to do 1/2 times x, or 9, whoops, 9 to the negative 1/2 there. And so let's see, that's going to be 1/2 times 1 over the square root of 9. Right? Negative 1/2 means you put 1 over that, and then to the 1/2 is the square root. And so it's going to be what? 1/3, so 1/6? 1/3 times 1/2 gives you the 1/6 there. What's that?
Shouldn't like if that's 6, the other one should technically be 1/6. If it's 5, it should be 1/6.
We're going to get to that. But yes. Okay, so yeah, so Brandon already sees it. There's a relationship here. The slopes are reciprocals, not opposite, just reciprocals. Now, so that's interesting here. So f prime at a particular point gives us one slope, and then its inverse at the inverse point is the reciprocal of that same slope. So I could alternatively, instead of saying g prime, what is g? G is the inverse of f. So g here, right, is the same thing as f inverse. Right? Isn't that true? The inverse of f is g. And so instead of writing g prime here, I could have just as easily said, f inverse prime of x, okay, is equal to 1/2 x to the negative 1/2. All right, so we're kind of like, there's a relationship here between a function in its derivative and the inverse, that function's inverse and the derivative as well. Okay, so that's what I'm kind of trying to show here. It's, again, a little bit tricky. We'll see how it goes. All right, and then number 4, let's try this again with, so let's repeat this. So repeat, I guess, like with the ordered pair at x equals 1.5. Yeah, basically we're going to repeat steps 2 and 3. So let's do that here. I'll kind of work with that with you here. So if that's the x coordinate, so we want to find the matching y coordinate with f. So 1.5, we're going to plug that into f, which is x squared. So 1.5 squared gives us, I think, 2.25. Whoa. Good so far? So let's find the slope then at the point 1.5, comma 2.25, okay, using f. So again, we know f prime of x is 2x, and so f prime of 1.5 is equal to 2 times 1.5, which is 3. So 3. And using the relationship we saw earlier, right, at 3, 9, on the derivative of the original function, we had a slope of 6. At the kind of like inverse point, the derivative of the inverse was 1/6. So here, using the same kind of relationship, if 3 is the slope at this point, then the kind of matching or corresponding inverse point, what do we expect the slope to be? 1/3, the reciprocal. And in fact, it will end up being that way. Slope at 2.25, comma 1.5, the inverse point there will in fact be 1/3. And just to show you, remember that the g is the inverse here, so g prime of x is equal to, what, 1/2 times 2.25 to the negative 1/2. And I'll just type that one into my calculator. So 0.5 times 2.25 to the negative 0.5. Whoop. And sure enough, it gives us 1/3. Okay, you can see it right there. Okay, so we can see that there's a relationship between the value of the derivative of a function at a certain point and then the value of the derivative of the inverse of a function at the inverse point. Those slopes are going to be reciprocal. So let me now we've done that. Okay, and that might be a little confusing. I get it. Again, this is not, it's kind of a tricky concept. So let me go right into the calculus now. The derivative of an inverse function. So, okay, the derivative of an inverse function. So here's the calculus. Let f inverse be the inverse of f. What?
Seems kind of redundant.
Right.
When you say it.
Believe it or not, that's how it's written in the book. So. We're going to let f be, and f is also a differentiable function. Okay, so let f inverse be the inverse of f, a differentiable function. Then, here's that relationship in summary of what we were just trying to show there. If I take the derivative of the inverse of f, that is equal to 1 over f prime of f inverse of x. There's that reciprocal idea. All right, there's the reciprocal of the derivative gives us the reciprocal, the 1 over the slope of the function at a particular point is equal to then the derivative of the inverse at the inverse point. Okay, and we'll do an example here because I know this is like all very. This formula you just need to memorize. All right, I can't again. I know there's sometimes like little cutesy things or whatever, but this is something you just need to have down. And then once you have it down, you can then like use it. Okay, so let me show you here. All right, let me show you how you can use it. How we're going to use it. So for example, let, I hope this fits. Let f of x equal x cubed minus 2x squared plus 4x minus 5. All right. And let's say I want to find f inverse prime of x. Okay? We will never need to find the value of the derivative of an inverse later in calculus. So why are we learning how to do it now? I don't know. I can't say. I mean, honestly, guys, I know, like, you might be, you might wonder why we learn anything about calculus because you'll never use it again in real life. I understand that. But, like, at least, like, everything we learn up to this point, I feel like, leads into something else. This leads into nothing else that we will learn. You'll never see this again except for the one question on the AP test and the one question that's going to show up on our test. Okay? So, I'm showing it to you though because it's not like terrible to get down as once you kind of are able to wrap your mind around it. It's one of those things. It's like you just got to see it a couple times and hopefully eventually it'll make sense. It is something that everyone in here is capable of getting down, but it's a little tricky at first and it leads into nothing. But again, I'm going to show it to you here. Now, one strategy we could do is just find the inverse function. Swap x's and y's, solve for y. But the problem is, if I were to try and swap x's and y's right here, would I be able to solve this thing? So if these all became y's, would I be able to get just y equals something in terms of x? Yeah, no. So that's the power of this, is that we can evaluate the value of the derivative of the inverse. So we can find the slope of the inverse even when we don't know what the actual inverse function is. Okay? So we can evaluate the derivative of something that we can't actually find, if that makes sense. So it's kind of crazy to think about. We can evaluate the derivative of the inverse of this thing. Even though we can't find the inverse, we can still talk about its derivative.
How can we find the derivative if you can't? Like, there's a line in the first place.
Using this relationship here. Using what we were seeing earlier. If I can find the slope of the function at a particular point, then the slope at the inverse of that point will be the reciprocal.
Find the derivative of this and then flip them and
So let's tackle this. So what I want to find, find f inverse of x. Sorry, I want to find f inverse prime of 3. Sorry, so I want to find it at a point, not at, I'm going to find an f inverse prime of 3. Sorry, not x, because that's, we can't do that, obviously, I just want to find the value. We can only find a value, I guess. So maybe, Connor, is that what your question was? We can't find the actual... Yeah, we can't find the actual inverse derivative, but we can find the value of the derivative of the inverse at a particular point. So there it is. That's what we want to do. Find f inverse prime of 3. So we'll go to our little formula here. F inverse prime of 3 should equal 1 over f prime of f inverse of 3. All right, so this is the thing we're trying to solve for. We have to simplify or evaluate this right-hand side. Now, you guys might look at this and say, Mr. Widmeyer, you just got done telling us that we can't find f inverse, yet right here we have to find what f inverse of 3 is. How are we supposed to find what f inverse of 3 is if we can't actually come up with f inverse using this function?
Find f of 3 and then take it.
So, close. So remember, guys, that this 3, that's going in for my x. So if I have f inverse, I have some 3 value, and I want to find that y value, right? For f inverse, I have a 3 for my x-coordinate. I want to figure out what y value matches that. Well, this point that exists in f inverse as 3 comma blank, what will that exist as in f? Blank comma 3. I know what f is, don't I? So if I want to find this blank, where does this 3 go? It goes in for the y, replaces, So we'll set our function, let me see here if I have enough space to do, I think I should. All right, we'll do it this way. So we're going to set our function x cubed minus 2x squared plus 4x minus 5 equal to the 3. Okay. How do we go about solving this?
Well, when I was tutoring Algebra 1 kids, there was a way to factor via grouping. Yeah.
Right, so we got to subtract 3. So first of all, and here's another big thing. So 2 big things I noticed on the quizzes yesterday. 2 big things I noticed on the quiz yesterday. Number 1 was we really missed a lot of product rules when we missed seeing a lot of product rules. And number 2, people were trying to factor like when stuff was written like this. Why can't we factor as it's written? It's not equal to 0. We cannot factor and solve problems unless this thing is equal to 0. So minus 8 equals 0. And then you're right, we can factor by grouping here. So these first 2 terms, what can I pull out? X squared. So it's going to be x squared times the quantity x minus 2. And these second 2 terms, what can I pull out? A 4. And that leaves me with x minus 2 as well. Sorry. Thank you for saying something, Brittany. And then both of these terms have what in common? An x minus 2. They both have x minus 2's in common, so factor that out. Okay? And now what? At this point, we can set each one of those factors equal to 0, right? So x is going to equal 2, and x squared is going to equal negative 4, but what's the problem here?
Imaginary numbers.
Imaginary. We keeps it real. So, the point here, 2 is the x-coordinate. So therefore, if we have the point 2, 3, and f inverse, we have what? 3, 2. And so now I can finally put some information in here. It's 1 over f prime of, what's f inverse of 3? According to this, an x value of 3 in the inverse gives us 2. And now we got to just find f prime of 2. And we got function. We have f, so let's just go ahead and find f prime. F prime of x is equal to 3x squared minus 4x plus 4. Right, pretty straightforward there. And we'll just find f prime of 2. So plug in 2. 3 times 2 squared minus 4 times 2 plus 4. Okay. So let's see here. 2 squared is 4. Times 3 is 12. 4 times 2 is 8. So 12 minus 8 is 4. Plus 4 is 8. So we get 1/8. And there's our final answer. Whew. Easy. We'll do one more. And then that's it.
Oh man, I just finished page 2.
Sorry.
Just make this one long enough that it's
Uno pas. I just finished a page as well, like you see. Okay. This next one is more typical of what you will see on an AP test. Okay? So like this next question you could consider like an AP question. So it's like, here we go, right? Our first like actual, this is what an AP question could really look like. This is probably taken from an old AP test too. I don't remember, but it's very much how you would see an AP question written. It'd be multiple choice, of course. Let f be a differentiable function such that f of 3 equals 15, f of 6 equals 3, f prime of 3 equals negative 8, and f prime of 6 equals negative 2. So you get all these like random points, and you're like, what? What am I supposed to do with these? The function g is differentiable and g of x is equal to f inverse of x for all x. What is the value of g prime of 3? Okay, so obviously right now we've already kind of like led ourselves into this kind of problem. We already have kind of, you know, an idea of what we have to do. Well, we just learned this in the derivative of the inverse notes that we did. We're probably going to use that formula that Ms. Rummeyer just showed us, right? Because that's what you do in a math class. You learn something, and then you practice the skill. When you are on your own, right, in a testing situation, in the wild, right, in the math wild, and you like come across this problem, how can you know, what can clue us in here? They're going to be using the derivative of the inverse formula. Because you see the inverse. You will see an inverse show up in like almost no other problems. But when you see this, you should be like, this is probably a derivative of an inverse. And sure enough, g of x is defined as an inverse, and they're going to take the derivative of it. We're going to find g prime of 3. So that is that whole derivative of an inverse. That should clue you in right away. I see an inverse, I'm taking the derivative of it, that's the derivative of the inverse. And then what you should do, without really worrying about it too much, I mean, really the next thing I want to see you do as a good idea is just like spit out that derivative of an inverse formula. So f inverse prime of x equals 1 over f prime of f inverse of x. Okay, just write it out and then we'll start tackling it. So the first thing here with this, right, so there's our formula. The first thing is that what's x? X is not x in this case, x is what? We're trying to find g prime of 3. And remember, g prime is f inverse, or sorry, g is f inverse, so g prime is really saying f inverse prime. And we want to find it at 3. So we're going to do f inverse prime at 3. So like so. Alright, questions so far on just that setup? How we knew what to put, where, anything like that? We're all okay with that? Any questions on just that? Just knowing that the 3 goes in for the x. We're all okay with that? And we're all okay with seeing that g prime is f inverse prime really here? Since g is f inverse, then g prime, so the derivative of this would be just this equivalent to taking the derivative of the f inverse prime. Alright, so now we're going to evaluate this. So again, I got to find f inverse of 3. What is the value of f inverse of 3? So it means there's some point in f inverse that has 3 as its x-coordinate and then blank for the y-coordinate. I'm going to find this blank. What is it? I have no other information up here about f inverse. No other information about f inverse. I do know about f. I have some information about f here, don't I? So f inverse has the point 3 comma blank. What will f have? Blank comma 3. So using my information that I'm given up there, what's that blank got to be? 6, because f of 6 gives me the y-coordinate 3 there. Notice, look at this little piece of information up here. F of 3 equals 15, that is a red herring. That is meant to throw you off. It is not useful. Okay? We're not trying to find f of 3. I'm trying to find f of what gives me 3. 6 gives me 3. And so therefore, in the inverse, if we have the point 6, 3 in f, the inverse will have 3, 6. So what is f inverse of 3? It's 6. And what is f prime of 6? In the information, f prime of 6 is negative 2. And so it's negative 1/2 is your answer. That's it. Okay. So it's easy as long as you can get past this initial setup, the memorization of the formula, and then the plugging in. Once you get past this, it's super simple. But you got to have the formula memorized first, and then also you got to know how to use it. But once you know how to use it, it's super simple. That's an easy multiple choice question to get down once you have the formula.
I wouldn't use the word.
Okay.
That wasn't that bad.
Questions on any of that?
Alright, if not, you guys are about time.
No. Well, last time math has been fun with like right now.
And
I wish I
tomorrow
could
we start
operate.
on related rates.
But I wish my body was
Related rates.
subconscious.
So you guys haven't talked to your ABC friends recently about the word related rates. It's probably like a 4-letter word to them.
They don't talk to us by the end.
Yeah, it's true. There you guys like pariahs, right?
They shunned us.
They kick you and
You're the bourgeois.
The lepers.
the bourgeois. Bourgeoisie. Get out here, you bourgeois pig.
We're like bottom of the barrel scum to them.
You're like the proletariat.
Yeah.
Bourgeois. The working class.
Okay, there, that's supposed to be a 6.
Oh my.
We bottom only, or is that all those?
Excuse me, so there's a little bit of inverse trig, there's a little bit of like implicit differentiation.
I wasn't, or Mr. But I wasn't watching you writing that. Is it both lines?
They are all. Yes. They are all master candy, and we are the mandated flavors.
I don't know if that's from
I mentioned that movie once, so you can't stop referencing it.
Sorry, Caleb.
Alright, like, did you know I found?
Yes, so if you guys want to go ahead